process of inflammation, right? Part of the issue with any kind of allergic response is we get a lot of inflammation. Then inflammation can impede, which is almost always the issue. Anytime you have impedance of oxygen coming into your body, you get a little anxious. For anybody who has asthma or kids with asthma, you can see just how scary it is for them. So yeah, you want to interfere with that to a point, right? So yes.
I don't remember if it was this class or my lecture that I asked if neutrophils were like they eat once and then
You did, and I was thinking, who did I responded? Neutrophils. You asked if neutrophils eat the, attack bacteria and things like that in blood. For whatever the reasons are, my brain was elsewhere, and I'm thinking monocytes. Monocytes do that as well. Don't think that I said do.
No, I mean, I found it.
Feces.
I found what I was talking about. You asked me to find it and then tell you. And it just says, neutrophils are one-shot cells. Once they eat a bacteria, then they kill it by the burst of oxygen, the stuff,
Yeah.
and then they die. So they're one and done.
It's part of, and it's, yeah.
I should tell you.
But I think you asked, how, where did that occur? I think I misspoke and said not necessarily in circulating blood. No, that's not right. Neutrophils do that. I was thinking just my brain was in monocyte land. So that was not quite it. All right? So if it's all right with you, to take a look at these, that one, and I'm going to put another diagram up that I think is better to show you a few things about how this initial injury takes place, and then some of these other factors that come in and what happens. And then there's this very simple equation for looking at where thrombin comes in. And if you remember some of your biochemical equations, where does an enzyme get placed? It's usually right there where the arrows are going. With the little, we usually use a triangle. And you know what it is. And then we'll see that. Right now, let me switch. Let me just say a couple of other things first before we go down there. So I'm not going to test you on this in here about prothrombin times and things like that, and how we use it. It's going to come up in lecture a little bit more, but I will put up a diagram to a couple of different views of it to show you how this clotting cascade works. What's important for you to understand is where are things and what do we need. So we actually need a number of things, but certainly calcium is a big one. There are other cofactors as well. So calcium is big. Where are these proteins made? Mostly the liver, right? So we're now adding more duties, if you will, to the liver's function. So that makes sense. The other is what happens if we go back to red blood cells, and what happens when red blood cells die, and what are some of the products that we could salvage and reuse, and what are some that we can't use at all and are also toxic. So again, looking back at red blood cells and ignoring everything else except the hemoglobin molecule for the most part. The iron in the heme molecule is at high levels and in different forms toxic, right? So we can't, we can make use of it to an extent. What are other products of the hemoglobin molecule breaking down? So
plasma membrane.
Pardon me?
Plasma membrane.
Okay, yeah, plasma membrane, not hemoglobin molecule. But yeah, so have you heard of bilirubin? And so what happens with bilirubin? And so what is it? And what, and think about the word. And it's associated with bile. So what happens is that we can essentially get rid of it, if you will, by dumping it into bile. It is what gives bile that green color in humans, or depending on your diet, but mostly, right, it's, you know, it gives it the green color. And your feces as well.